Laurens, I know that you've gone through a couple of PyBricks updates recently, one to improve BLE support and another to give block-based development. Did you want to quickly?
Yeah, sure. I didn't really prepare a presentation for today, but yeah, if there's some time, I'm happy to share some updates. I think it's been a while since I've been on here. So for everyone else, PyBricks, Matt just introduced it, is basically MicroPython for all of these new Lego microcontrollers. So, and then not just Mindstorms that used to be programmable, but just everything that runs on batteries these days has a microcontroller. So naturally, you'd want to run MicroPython on it. So that's what PyBricks is. And lately, we've been doing a bunch of huge updates. So there's async now for multitasking. There is Bluetooth to communicate between all the hubs. But then also, just yesterday, in fact, we announced block coding as well. So this really, and I'm just going to share my screen now then, brings together a lot of this stuff we have been working on over time, from Python to MicroPython and now to blocks as well, to really provide this all-in-one environment for Lego coding. So not just Mindstorms again, but all of the other ones as well, all in a unified environment rather than a bunch of different apps that restrict you to particular things you can and can do. Now, I guess for some of you, block coding might not be the most interesting, but there's still a few MicroPython bits that are quite interesting. So I guess I'll focus on those here. I'm wondering if the screen is getting through on the presentation.
Yep, I can see the block window. Yep.
All right, so this is still the same environment as it has been before, except now when you create a new script, you can choose between blocks and Python. But in this case, here's a demo of a block. So as I mentioned, you can control all of these devices now in one app, but I'm just going to close this documentation. But unlike any of the Lego apps, you can also get a code preview and see your MicroPython generated live. So if you're new to MicroPython coding, you can really easily just change things and see your code change instantly. And this is true both for synchronous code as well as asynchronous code. So this is a pretty simple synchronous example. So we can just run this, which is going to print hello and play a sound, in this case, if it came through. Yeah, so, and before I show you the async stuff, another, I guess, departure for most block languages is that there's this explicit setup. So you get to assemble your device or creation in the same way that it looks offline. So you just build it up, and that helps you structure your code. And in this case, as you can see, that instantiates all the variables and objects that you use throughout the code. And I guess some of these stuff applies to MicroPython more generally, not just Lego stuff, where I guess in the presentation we just saw, there's all this pin initialization, which could be up here. And then the main code begins to run from here. And again, that changes live as well. Yeah, but again, since we're all here for MicroPython, I guess I'll zoom in on that. So this is a synchronous program, but if we take, for example, another start point, then it switches to async to run those things at the same time.
That's cool. Yeah.
Or if you don't want to do that, you can also explicitly use a multitask. I guess before I drop this here, just giving you 10 seconds to think of what that code might look like. But this block is basically going to be similar to what would be gather in async IO. It's a little bit different here, but just the same. There's nothing in it at the moment, so I should put some blocks in to show you what that might do. Say that we would like to run a motor, but then also turn a light on, which I should pick the color light because there's no device for the other light here, which is not an async operation, so it still doesn't do anything special. So it figures out that it needs to do that just synchronously. But if there was something else in there that was awaitable, then it would set up that subtask, await that operation, and then do the synchronous one, as well as the main task, and then run all of those together. So that's where this multitask shows up. That's this block. So there's really quite a lot you can do, also far beyond most of the official apps. And again, not just for one hub, but for all of them. And then to make that a bit easier, also, you can always open up the documentation for each of those blocks. And that gives you both the block version as well as the Python version for each command. So the blocks are really designed to match the Python API. So hence again, that setup and that program. So yeah, lots to explore and lots you can build and gradually get into MicroPython.
That's really cool. I love the way you've integrated async there. It's
yeah, I figured that would be the most popular thing on a MicroPython talk.
Yeah, that's great. You definitely have to bring those Lego robots next time, Matt. So
I've got them right here. Yep.
Yeah, and even if you transition to MicroPython later, it's a really quick way to get started. But I guess another MicroPython thing specifically that's good fun is that I'll just open up this as a reference and close the docs. You can mix blocks in Python as well. So you can really quickly together build some blocks and then later on switch to MicroPython or write a separate piece of code. So actually, let's do that. So create a Python file. Let's just call it example and I guess not use a template in this case. We can do, or I guess call it square of x and then turn x squared, right? So we might do that to find it here and then import that function so that we should now be able to use it. So hopefully, yeah, so this now prints 25. And that was all just a MicroPython code. And I mean, there's a ton of interesting things you can do. You can, so let's do one without parameters, but just say, oops. So if we did this, so this is something that you wouldn't really be able to do in blocks, but you can do it in Python. So in this case, it has no parameters, but what we can do, we can iterate over that thing. So, and all of these things is something you can't really do in most block languages. So it's kind of bridging the gap to Python without having to do all of it in Python right away. And again, hopefully this will work. Oh, I made it print hello in this case, but I'm supposed to make it print the item that it was iterated from. So there you go. So we just built a generator that we can iterate through in the blocks. So you can really mix Python and blocks this way and just gradually move on. Yep.
Very cool. You must have given that considerable thought before implementing it. That was great.
Yeah, because I mean, there's plenty of block languages out there already, and we didn't just want to make another one. We really wanted to make something that was both really powerful, but also made the transition from blocks to Python a lot easier, while at the same time not restricting it to any particular product, but all of them. So in principle, this is the one app you would use if, whatever you want to build. And it also has tons of features for like kids in robotics competitions as well, but also for hobbyists who want to build, I don't know, training layouts or all sorts of robots that you can build this way. All right.
Very cool. The BLE update.
Oh, yeah. Yep, there's that as well. So you can, there's a hub configured here, but you can tell it, I mean, this is some stuff for the IMU, but you can also tell it to broadcast data on a particular channel. Let's from 0 to 255. So let's pick that one. Or listen in on any number of channels broadcasted by other hubs. And then to make use of that, what you can do is broadcast a bit of data for other hubs to listen to. So to make this a bit more useful, what you could do is have a loop that would, and I guess I should bring up the code so you can see what's going on. To broadcast some data, this isn't particularly useful, but we could say measure some angle of the motor that we've got there, and maybe also the pitch of the hub that could be useful for some reason. And that is now broadcast over the air wirelessly for other hubs to listen into, which on their end can then receive that. So using the observe block. So that's a counterpart to the broadcasting stuff. So they could, in this case, it's configured to listen to those channels. Again, you would normally do this on the other hub to listen to this one. But this would then print the data that was broadcast. And it encodes all of that into the advertising data. So in principle, you can easily just, as long as you encode it in the same way, also listen in on a Raspberry Pi or something else that just knows how to decode or encode that data. So I think it's up to about 20 bytes worth of value. So in this case, it'll figure out to encode all of them as integers in this case. But yeah, it also lets you encode text or floats up to 20 bytes anyway. And then it'll be received and unpacked in the same way on the other side.
Yeah,
yep. So yeah, there's that too. So if anyone wants to talk to their Raspberry Pi or the Pico and so on, yeah, that should be doable as well.
Very cool, making great progress. It's awesome. Thanks for the spontaneous demonstration. That was great.
No problem. I just saw that the presentation was on. Somebody posted it online. So, yeah.
Cool. I